things. And each time you feel it's gotten out of the way, feel free to say what should be done to correct it, right? So as usual, you can keep your own heading, but because of time today, I'm going to get rid of the heading as well, so we can think around things, right? Last time we started playing with pointers and we were walking through the slides and other things and all those kind of things, and we've got a video recording that you can watch again. But again, that bit was, I think we spent quite a short time there. So I want to sort of explore it a little bit further. Remember, we said we use pointers for memory management. So pointer is basically like, it's just an alias to a particular variable. Just basically point towards the address of that variable. Yeah, does that kind of ring a bell?
Yes, sir.
Well, thank you. So we want to try something. Let's make up some stuff, right, as usual, right? So let's go for, we'll still go back to going according to the books at some point, but let's go declare a variable called X, right? And let's say we want to print out the address of X. So we can, one, print out X equal to, and we print out X, and let's end the line there. And we also want to print out, I mean, for now, we understand that this is just an output command, right? It's just outputting to the screen. It doesn't save anything. Is that correct from our discussion earlier?
Yes.
Thank you very much. So we say we want to output address of X. Will this be correct if I just write only X, or I need to put something to X to make it work?
You have to add that end thing. I don't know how you call it again.
Wonderful. Thank you very much. So we expect that this will print out the address, right? Yes. Let me see. Let's run it and see what happens. Oh, it's going to come up with a server lost connection thing again. Oh, it's coming, it's working, good. So at least it printed out the initial value of X and it printed the address for us. So we can actually initialize S at some point to, well, same point, to make sure that we print out something. Okay, good. So similarly, the same address, let me see, I think 4010. Wondering if it's the same address each time. Yeah, it generates a random address each time because it's an online compiler, isn't it? Right, so let's see if we declare pointer as well, right? So to declare pointer, what do I need to precede the value with?
Star.
Star. So I can call it pointer if we want, and I will say the pointer to X. Would this be correct if I just say pointer to X is actually X? Would that be the correct approach to declaring a pointer?
Should we do IP there?
That is just a variable name. So we can give it any name, right?
Okay.
Let me, just in case, pointer X. Okay, so remember the pointer points to what? The address. So to get the address, we need to put the and symbol in front of it, yeah? Does that sort of ring a bell now?
Yes.
Okay, so let's try it out to see what happens. But at this particular point in time, so we've got a pointer pointing to the address, and we just want only the value that is stored in it afterwards, or in terms of what it is pointing to. So this says we want to point to something. So let's run it and see what it's actually pointing to. It's pointing to exactly the same address. So if we want the variable value in terms of, we want to say, okay, this alias, what variable does it point to? So just say variable pointed to by pointer. Let's say value. I think it's best to put value of variable. Then that's one, we would just precede it with a star. So in that case, it prints out the actual value for us. Does it make sense up to this point? Does it feel like a good recap? At least help clarify things that we did last time?
Yeah.
And we want to play with pointers, but also something like some string pointers and other things, so pointer to a string. And again, we are just going to write a bunch of code, which we can do copy and paste at some point if we want. So pretty much we want to add a string. So to include a string, we need to include what? The string library, right? Somebody talk me through it. What do I type there?
Include string.
Was that Nahil? Was that you? Destin, I always like the sound of voice in the background. Nahil, was that you?
Yes.
Thank you very much, Nahil. Nahil doesn't like sweets too much, but still you would have gotten a chocolate, right? So we include a string header and we want to define some variables. So, right, we want to define a variable called food and we want to assign it to pizza, right? So initially assign it to pizza. So we have the string, that's the data type, and then the name.
Sir, you forgot to write R.
Sorry?
You forgot to write R in the string. It's thing.
Oh, it's not B. Thank you. Who was that? Isha, thank you.
Yes, sir.
Oh dear. Sting. So what to declare, thanks so much. We want to declare a string called pizza, right? And from the pizza, we want to declare a variable pointer to that particular variable. The only thing that we would do differently right now is that previously when we had an integer, right? When we had that int x earlier on, right? And then we gave it, I don't know, 19, I think so. And when we declared a pointer, right? So we had, remember the pointer is of the same data type. If you think about it, if you want the pointer to carry the address of the location, and you know different data types occupy different space in memory, it makes sense that the pointer should be of the same data type. So at least it can occupy that space, right? Okay, so we earlier on we have a pointer and we call the pointer, we can even call it port if we want. We notice, and please pay attention to the location of the star, right? So for a string it's slightly different, right? So we want to have a string pointer, so we just call it, again, I keep writing string. So in that case, we have the star coming before there because we are pointing to an object, and we can call it string pointer, or let's call it PTR. PTR, doesn't matter. So pointer to food, and we need the address, and then we need the name of the variable we are referring to. Okay, so we want to do similar to what we did with the integer data type, and then we print out the name of the variable, the value stored there, and then of course we can print the pointer if we want. So in that case, we copy out the name of the variable, the value of the variable. And we can put end line or we can put \n. So we can mix match them. Let's go with end line here. And again, copy out, and then we have the pointer itself. Let's go for the pointer first. And let's go for the \n. Yeah, it's funny, I was struggling with \. And we copy out the address of the food as well. And we can combine that with end line. And we can again copy out what is being pointed to see if it complains. And for that, we can do \n. Shall we try it out? Yes or no? I want to make sure you follow the code up to this point at least. Are you happy for me to proceed?
Yes.
Thank you.
Yes, sir.
Thank you. So we've got the first one. I mean, we can print them out. The first one, which was just the food, printed the value stored in the string, and then also we printed out the value of the pointer in terms of the address is being pointed to. That printed out, of course, the address, and again we printed the address of that food itself, which is what this does, takes out the address and passes to the pointer, and that printed it out for us. And then we have the of course pizza coming there. What if I did this? We've got something completely different because we cannot pass the address to a variable. I hope that makes sense, but a pointer makes it work. So again, do you want to try this out yourself, or you want me to carry on? I'm going to copy my code for you. Try it out yourself, but I want you to have a different pointer variable name, and I want you to point it to KFC, since we had KFC earlier, right? So you've got the code in the chat window now. Please let me know when you're ready to continue. This way gets interesting. If we look at the code carefully, at this point, well, we've got a variable and then we've stored a variable, we've got a pointer, and then we've stored that using the pointer. And what we have in this particular location, in this particular variable, the pointer variable, is an address. So currently, this particular ptrf is a pointer to the variable food, right? So it's a pointer to it. If we want to get the actual data stored in it, which is if we want to change it from being a pointer, if we want to dereference it, right? If we want to stop it from being a pointer that references to an address or refers to an address, if we want to dereference it, we use the star. So this approach is actually what we're doing at this point is called pointer dereferencing, right? We just removing the reference from there. Does that make sense? If it makes sense, I'm more than happy. Yes, it's just a terminology.
Can you repeat again? I did not
So
hear it clearly.
I'll put the terminology in the chat window. I'll put a term in there. And what I'm saying is that, you know, at this point, when we just printed ptrf, it gave us the address. That's this particular line. Yeah, the second line there gives us the address of what is being pointed to. It's just a reference to an address, okay? So if we want to print the value, if we want to dereference that pointer, what the pointer is pointing to, we precede it with a star. So whenever we pass this to another string, it's just going to pass the value itself. So it's a dereference pointer value. Does that make sense? So the star is called a dereference operator. Does it make more sense now?
Okay, so yes.
Okay. Let me write it properly for you and put that in the chat window. All right, so a bit more play with things, but this one will be obviously is easier to see. It's better to see it than actually to see working than actually just to talk through it. So I'm going to get rid of things. And we started off, thanks to Nahil's question, we started off by talking about arrays, right? So you can have an array, which is sort of a list of data types, right? You can have an array of data, and this particular array can be pointed to by a pointer. It's just interesting that we say the pointers and arrays, they're kind of synonymous. So you can have a pointer to an array, but it will basically just be pointing to the beginning of that array, because array normally reserve the memory space, and the next information is stored in the next memory space and onwards as well. So normally to access members of an array, you use something like a for loop, or you use a loop to access the members of that particular array. So let's say if you point to the first element of an array, so the contents of an arrays are called elements. So if you point to the first element of an array, you can use pointer arithmetic or array arithmetic to assess the other elements of that array. Does it make sense so far? I know we started off by talking briefly about arrays, especially the array bit. We're going to see it practically anyway, but does it make sense so far?
Yeah, sure.
All right, so let's say we start off by defining a constant, and these examples are quite similar to what is in the material anyway, so it'll be a lot easier to understand. And this constant, we can call it anything. Remember that is in this case, we just choose to call it max, right? And we want to assign max to 3 in terms of it's just a variable constant. That's all it is. It's an integer constant. And in the main function, we want to start off, let me get rid of this so it doesn't get in the way. And this time I'll remember to keep the return 0 as well. So we want to have an integer array, and the array is called var, and this var has a maximum of max, which is in this case max 3. So it's got maximum elements of 3, right? And we want to define that array. So we've declared it, but we want to define it by giving it some initial values. So initial values we want to have, let's say 10, 100, 200, for example. It can be any content, doesn't really matter, right? So this is how we declare an array. We just say it's going to, we expect it to contain a list. We don't have to give it the maximum value, but in this case, we set it to 3. And then this is how we define it. So the first element, second element, and third element. In terms of index, as far as C++ is concerned, the first element will be index 0, second element will be index 1, and then this will be index 2, which is what, how we access the element. If you were doing a MATLAB, then the first element will be index 1. So for most programming languages, first element is 0, but for MATLAB, it's index 1. That's something to remember as well. So first, let's have our pointer. So we have an integer pointer. And of course, you need to proceed with star, just as you said earlier. And remember, the PTR is just a way of a name that we give it to show it's a pointer. It doesn't have to be PTR, but it's the dereference operator that is important when you are declaring a pointer, for example. Right. So for the start, we want to have the element of the address of that array, and it's slightly different. We've seen one difference in terms of when we're using a string. So for the string, we had like the name of the string, and then we have the string. We had the data type, which was string, and we had the star closer to it, and then we had the name there. For an integer, we have something like we have the data type, and then we have the star, and then we have the name of the variable there, or variable name. So for an array, we're just going to pick the pointer name itself without the reference operator, and we want to assign it to the array to get the address. Okay, so at this point, we've assigned a pointer to the array, but it's pointing to only the first element at this particular instance, right? It's pointing to only the first element. So let's have a for loop, for example. Just bear with me really quickly. Just bear. So back up. Right, so basically we're going to have a for loop to access the individual elements. So basically we can just have for something like this, we can do for int I to I less than, we've already been to a for loop before, less than I equals 0. Let's assign I to 0 because it's going to start from the 0th element. Index, and then I less than max. Max is 3, remember, and we do I plus plus. And in here, we want to copy out the value of I. but we want to copy out the ith index. Remember this. So if we go to the array, we pass in I as an argument to the, well, as an into the elements, and we want to print out the value in that particular position. So let me end line here, and we want to print out the value in the array. So it's going to be var. So if I equals 0, we want to print out what is in 0. If I equals 1, 1, we'll print out what is in 1, then we'll go to 2. So 0, 1, 2. Let's try it out to see if it complains. It's not complained yet, and it's printed 10, 100, and then 200 for us. So we use a for loop to assess the individual elements. If I change this to 1, it wouldn't print from 1. It will print from 100. So that shows that, of course, the first index is 0 in this particular case. For the benefit, comment this out so later you can try out the code and know what we did for that side. But we want to use a pointer to access the elements of the array. So similar to what we did, we're going to have a for loop. And in the for loop, we're going to have an int I, and we assign the I to 0. By the way, are you happy for me to continue? Do we understand stuff up to this point so far? Brilliant. Thank you very much. I will continue in a few seconds as well. Okay, so int I less than max again. And I want to do I plus plus here. Why do I keep doing the capital I? I plus plus at this point, and I'm going to open and close the brace, right? So I want to start off by copying out some things. So I'll say cout. And first of all, we want to type out the address of the variable. And we will just want to say address of the variable at index I is. So to do that, it's just some editing, really. Equals, so what this will take is just type out address of var I, which is 0 at index 0 is, then we do index 1 is, and we just continue, right? So let me go to the next one, and we want to use the pointer to access the address because we've already passed it, the variable to the array to the pointer. So I'll print out the pointer. And earlier, when we did this without the dereference, it gave us the address. So we're going to print out the addresses individually, and we'll end the line here. So that takes care of the first thing we want to do, and we want to also print out the value. So the value of the variable at the ith position is equal to, and I'll end there, but I'll write on the next line. So that is equal to the pointer dereferenced operator using the dereference operator, right? And we end the line there, and we can remember each time it's just going to print out at this point. It's just the value of the pointer is only pointing to this. Let's try it again. Let's try it out. I've commented out the other one, but remember that the pointer points to only the first location. So I try, and then it starts off by saying the value at 0 is that address, and then it points out that one, and it says the address of var at 1 is that, it prints that out, and it goes on, but it says the value is 10, 10, 10. So even though the address is changing somehow, even the address is the same, sorry. Even though let me copy out I as well. You notice the ith position is changing. You've got 0, of course, the value is 0. You've got 1, and then the value is 1, and you've got 2. But at the same time, the pointer doesn't change. What is happening? I keeps incrementing itself each time, right? It increments itself by 1. but the pointer is only referring to the first one. So in terms of the value, without the reference, of course, it's when you dereference it, you get 10. Well, when you go to the address, it's still exactly the same address. So what we have to do at this point is to increment the pointer each time. So we have pointer plus plus. Then if I run it, I have now updated it. So the first time it printed the address, then it printed the value, this time address, and then the value, again, address, and then value for me. Does it make sense? Thanks for asking, right? So what we have done here is simply saying we intend to define an array. You are comfortable with the array part, isn't it?
Yes, sir.
Okay, we intend to define an array which will have a maximum of 3 elements. Yeah. So in the first code, we define an array and then we give it some elements through the definition. So we say 100, 10, 100, 200. We can just change this right now to, that's the benefit of having to 5. So then we just say 300, 400. Yeah. So we have 5 elements of this array. And what we did in the first instance was to show that the index starts from 0, and then the var I just simply print out the value in that particular location. Is that okay up to this point?
Yes, sir.
Right. So then we create a pointer called PTR, and then at this point we just show the different types of assigning pointer variables. Like if it's integer, we will have the dereference close to the pointer. I'll comment that out. If it is a string, we will have the string and then the star closer to the string and then the pointer name. But if it is an array, I mean, this is the point where you do the assignment, right? If it is array, you simply use what we have here without the dereference, because we've already created this as a pointer. You assign it to the array, but what it's actually doing is that the pointer is only pointing to the first element. So
Okay,
it points
sir.
to the address of the first element. So when I do pointer plus plus, it's going to the address of the second element. When I do pointer plus plus again, it's going to the address of the third all the way to the 5th. Does that make sense up to this point?
Yes, sir.
Okay. So knowing that we just want to print out these values or the addresses. So first of all, this one is just for beautification. So we can have it show address of and in there. And the I is saying currently we're on 0. So when we do the pointer, it will definitely point to address 0 when we first print out. To get the value, we dereference it. So that gives us the value 10. Does that also make sense?
Yes, sir.
So when we do pointer plus plus, remember pointer is pointing to, it's just an address. So when we do pointer plus plus, the next one is the address of 100. So when we say, of course, address of index 1 is the pointer, which is now the address of 100. So if we dereference it, we get 100. So the second time, if I run it right now, just to get, because we've updated to 5, it keeps going all the way to the last element. Does that make more sense now?
Yes, sir. That's perfect.
Thank you very much. And Ethan is understanding of this. And we did say that we will sort of take our time to break this down if it gets in the way. But I'll bring the recording to a close here.